Hi everybody, so let's get the camera installed and start doing some calibration stuff. So we got quick release already aligned. I know when we do it like this, then it's going to be perfectly in the middle between all the lights, the lens I mean. And let's also get our turntable up and running, even though we support some of the turntables like that one directly, but I want to show how to work with any turntable off the shelf. And let's get our software up and running. Let's run the turntable software, connect, and we're done. Let's make sure we can control it. Yep. That works. Now let's go back and launch our rig control software, so everything gets connected. It's powered on. Let's get some lights on there. Let's turn the camera on. So there you go. Not aligned. Let's adjust it a little bit so everything is aligned perfectly. Go to autofocus and make sure. Let's find some good spot there for over there. Probably something like that is good. Then we'll go back to manual focus, because I already scanned that prop at that specific distance many times, so I know that good values for that are 1/15th of a second, f11, f18th, and ISO 200. For this specific lens and camera, if we go to f22, it's going to be too blurry, because we would be hitting diffraction limit at that point. And something like f16 would just give us shallower depth of field, and we'll have more blurry areas. So f18 for this prop seems to be at this distance seems to be like a good compromise. So everything is centered there. In terms of what we do in terms of settings here, technically speaking, we want to match exposure value for all the lights with exposure value in the camera. However, here's the trick. Let's suppose we do, so we had 1/8, let's suppose we do 1/15th, the same that matches the camera. So before we try to trigger, let's get our trigger connected, because I already forgot about that. Connected that, and let's plug it in into the top sync box, the main one, the channel 1. Okay, seems to be fine. Let's try and trigger the camera. Definitely something happened. Image is written, so that's good. Now let's try to flash that one light with 1/15th that matches what we have there. So what just happened? Unfortunately, we have nothing, just ambient. And just for video recording, I have this extra area light there that will actually turn off when we'll do the actual scan, so you can see it affects the image a little bit. So what happened there, this is where we enter this land of awesome consumer hardware that just doesn't trigger when you tell it to trigger. It has some delay, and some of that, specifically in this camera, even in manual mode, first we need to do the half press. When we do that, I repeat it again, it's specific to this camera and this lens, and for all different combinations that might be different. As soon as do the half press is the same when you do the half button, the aperture on that lens changes from whatever default value is to the working one. It takes some time. So now when I go and trigger it, what do we have? Oh, we still have nothing. Okay, great. Now let's go to 1/8 of a second. Do the same trick. Make sure we're half pressed. Flash. Oh, there you go. Now we're getting somewhere. And to be clear here, that we have tested the whole lighting system up to 200 frames per second with machine vision cameras, and that trigger signal fires off right away. And unfortunately, this is what you have to deal with when working with this type of consumer grade devices. What I'm trying to show here is that, there you go. So I did trigger it again, half was pressed, but the image is like halfway done. So lights went on for 1/8 of a second, and only after a while, almost when it was finished, at the end of that, that's when the trigger started, and that's when it started to do the capture. So as you can see, it gets tricky. You have to find optimal parameters there. In our software, on top of that, you have what's called maximum frame rate or frame rate limit. That's another thing. To basically test that, how much your camera can handle in general, you basically just do the half press and then keep pressing and measure, start the timer, and see how long it would take for you to basically pressing like that to take all 24 photos. For this camera, again, theoretical is around 3.5 frames per second, but practically you cannot really do that. It cannot handle it reliably. 2 frames per second is on edge. 175, it's like somewhere on that front. And to be completely sure, we set half a frame, like half a second exposure time for lights. So essentially light comes on, then we send the trigger, then at some point later later on the camera will decide, okay, now let's take the picture. Then we wait a bit more at that safety time, and the frame is done. So for this specific camera, for also that specific SD card, just experimentally I figured that to be safe, so we don't have any misses, half a second, 175 frames per second would do the trick. So what we have here, when we start the sequence, there's also what's called start delay. At that time, when a turntable commands to take a picture, first we do the half press. Again, Canon cameras would do it differently. Sony cameras, like different cameras, do it a bit differently. So we do the half press, we wait half a second, and then we run the sequence. And over here, to trigger the sequence, we can actually do the we don't have to turn it off, but we could. We still don't have the filter on it, so we're just testing that we're gonna take. So right now we have, well, let's go and, so it's easier, let's go and format, erase everything on that card. When we trigger the sequence, we should have 24 images there. Okay. You might also get a better SD card if that's an issue. So let's do run, trigger the sequence, and as I said before in previous videos, we make sure that it's in silent mode, meaning it uses electronic shutter. Also, all autofocus is disabled, all image stabilization is disabled, so it's just that. And over here, it also in our app, it computes how long that sequence would take. So 14.2 seconds. If we go to play, we can see, okay, 24 out of 24. So we took 24 images, we check like, yes, okay, that's all good. Keep in mind we didn't install the FPM on it yet, but it did. Okay, let's do it one more time just to check. And 24 plus 24, it's 48. Okay, let's run. It's running. And as I'm walking right now here, the whole building is wooden, so as I move, everything shakes. So when we fire the actual scan sequence, I'll just step aside to make sure there's no motion or anything like that. So let's go back, and we got 48. So this is something that you might have to play with for your specific camera. This is $2,000 camera. It's a really good one of the best sensors. We use it a lot in production, but people say, can you make it faster? Well, absolutely. You can use Ximea, IOI cameras. There are custom built for machine vision that can use PCIe and stream at like 20-30 frames per second reliably and react in like a few nanoseconds. But they cost 10,000 plus, and the price goes up there. So here we'll work with what we have. Another thing that I also have to say before I forget is the format that we save in. In previous videos and introduction videos, I did talk about JPEGs, and we have some special settings that we use. Another thing here is that that would depend on SD card that you use and how quickly your camera can write. Here I have it set to fine. If I set it to extra fine, check this out. So we run the same sequence, trigger it, and there you go. So that was 24 plus 20, 48, plus 24, it's 96. So we should have 96 images here. However, pay attention to what happens to that red dot, and it's still writing. We go to, and it's still writing 8, 7, 6, 5. If we start the new sequence right now, that number will go up. Okay, 72. Was it right? I didn't do. Where is my phone? Is it the right number? Let me check. 24 plus 24, 48, 72. Okay, that's correct. Whatever I said before was not the right number. Anyway, you saw how, like, when it finished the sequence, it was still writing. So if we quickly turn to the next position and start capturing, that will accumulate, and eventually what's going to happen, it will stall and start basically misfire. So this is something, so this FPS frame rate that we have before, so that's when it's limited by the sensor and capture capabilities in general. But right now, when we use Xfine, essentially those JPEGs are 2 times larger, and they keep piling up, and essentially that frame rate we would have to reduce even more to maybe go to like 1 frame per second if you want that quality with this particular camera, with that particular SD card. So again, from experience, most of the props that we scan, I know that there's practically no difference between fine and Xfine, so we'll just go back to where it was. JPEG settings, use fine. Another thing that we also use quite often, if for instance, to help with that problem specifically, if you use Xfine, is aspect ratio. So if you scan a prop like that, what you see right now, that octopus, it's pretty much square. So technically there is really no reason to have, so right now it's 1 by 1, so everything is cropped off, and it's perfectly fine, and it will also help with those write speeds, and might prevent all those problems with misfires and so on. But for now, we'll just, to make it simpler, just go back to original full sensor. It's 60 megapixel, but it's fine JPEG as opposed to extra fine. If we go to extra fine, it will do like maybe 80, 90. We have some clients who report that it would shoot and then it would, like, at the end of the sequence produce some garbage, or like not the right amount of images, and that's specifically because of that. So one solution is that if you absolutely need that detail of X-fine quality, then slow it down, reduce it even further. So we talked about that. I think we covered everything there. Most of other settings, we have them written in documentation. For most of other stuff, you don't really need that. At this point, as I said, I have already pointed all the lights to where they should point at. This is where this octopus is going to be when we'll scan it. But right now, we need to attach an FPM, a polarizer, and make sure that all that works correctly. We have options to turn that on and off, and then we'll make sure that everything is set correctly there. So I'm gonna grab an FPM over here, and first, as I was showing previously, I'm going to detach the adapter ring and first screw it on, because this way it's a lot easier to install it this way and not break anything. So there you go. It's on, it's secured. So the actual FPM, the orientation doesn't really matter, so it's whatever is convenient, but there you go. I put it on, make sure it's secured, just wiggle it around, everything is good. Take the cable and connect it to, actually it could be like any box really. They're all by default just outputting the same signals. So I connect it to the one that's called A, make sure that the cable is loose. As you can see, the image here got darker, so that's good. And we can see that something is going on. There are changes. And let's get our Christmas toy over here. It's a bit dusty. It doesn't have to be super accurate or precise. What we do want to do, however, is to make sure that it's centered the best. Let's check, go to autofocus. Why it's not oh, there you go. So the trick right now is to make sure that we basically want to align this ball with the center of the camera, so that later on it would be a lot easier to do the calibration for this thing. So let's move it up. Oh, there you go. So it's good that it's made out of plastic, because if it was glass, probably would be dead by now. Okay, let's put it back on. So we need to lower it a little bit. Come on. It needs a bit, maybe, yeah, let me try this. So I have this thing, we put it like this, so it's not going to go anywhere. So a little bit down, lower a little bit. Yeah. Maybe a little more. That looks good. So that, I think, looks pretty quite centered to me. So I would say we'll leave it like that. So what happens here when I'm touching the focus manually, it goes to zoom mode, so it's easier to see everything. So right now, let's go to our app. We have switch between parallel and basically filter control. So we need to enable cross polarized. And now the trick is that, so you see, like we start, well, let's say let's start with this light. So I maybe to make it easier, I show it on the first one. We get to key, we have just one single light. Let me turn that ambient light off. So, and what I'm doing right now, I have cross on and I'm turning that polarizer filter until that little highlight is as dark as possible. Let me check on camera. So yeah, I hope you can see. Yeah, it looks like you will be able to see it. So right now it's pretty dark. So if I switch between it on and off, you can see that that's the change. So now we do the exact same thing, but I don't need to do it one by one. So I'll just go to this ambient, to this all light mode, and basically you will see. So right now I'm going the next one, done. So right now all of them should essentially be very dark and almost disappear. Good. Next one. All right. Okay. Keep going. All right. What about this one? Good. And I guess that will be this one. So this is pretty good. There may be a little bit off there, not like you can get a little bit maybe closer, but none of that is really critical there. So I would say that's pretty good. And if we turn the filter off, you can see how bright they are right there on the camera. Let's turn that on again. You can see how bright everything is. We turn the filter on and off, and that's the difference. So that's pretty good, but you can also see, this is what I was talking about. I touch the thing and the whole thing wobbles there. So we need to, again, we need to add some weight, sandbags, whatnot. But if I don't touch it too much, after about 5 seconds, it's rock solid. So we'll just keep going like that. So we got our light right there. Let's oh, it's in manual mode. Let's go to auto. Focus to that. Okay, that's good. Go to switch to manual. So lights off. I'm not sure if the camera captures that, but you should see all those waves going there. Probably it's too fast. Anyway, turn that off. Turn our light for video recording off, so it doesn't throw us off, so we see all our stuff. So now we basically need to capture this sequence just once. As I said before, when we ship these rigs with the software, everything is already pre-calibrated for roughly this whole arrangement where the camera is in the middle. So if something is roughly in the middle, it would be good, but it's a good exercise to do that calibration step. So there you go. Let's turn it off. Let's see, did we capture anything? 73 photos. Let's go and make it all clean. Format the card. So we have our first 24 photos would be those mirror ball calibration shots. So there you go. That's fine. Let's now trigger the sequence. Make sure we are in manual focus mode. Good. Go. There you go. Looks like it's all good. Yep, we got all our 24 photos, and as you can see, that's the sequence that we expect by default. So when you do all the wiring in our documentation, it tells you like which light goes to where, to what socket of what box, and so on. So first we have all the shots that have specular. They kind of spiral counterclockwise, starting 3 o'clock, go all around, then 24 shots, and that's it. So if we and these are the shots that we will be using, basically align virtual virtual highlights with the actual one in the shot. It also, at this point, let me turn this light on. It's also yeah, if we could zoom in, preview, whereas I'm trying to, yeah, there you go. So yeah, that's a pretty good highlight. You can see we can zoom in, we can even see all the individual LEDs in there. So that's pretty good. And let's turn the filter off. That's an image. Oh, that's there you go. Throws me off. Okay, there you go. Off, on, because that one light I'm just adding that manually so you can see the rig around. So, okay, anyway, we got all our 24 photos there that we'll later use on PC when we look at the software, how we calibrate, or I would rather say refine the calibration. And at this point, I think we're done with this bowl. Another thing that's before starting and trying to scan something useful, it's a good idea always to scan at least one loop. Ideally, you don't need the whole loop, but you want to have something for reference. So in this case, we're going to run like a quick, basically probably 8-position loop of this guy. We can use either the software manually, make sure that it's all aligned. So this thing would be useful later on to validate that all our exposures and everything are set correctly.